Welcome back to Element 14 Presents. I'm Clem and I need a security camera for my workshop. But I will not buy any dodgy cheap IP camera because you cannot trust anybody's claim that they will not abuse your data. You have to control it. That's why I'm building my own one from scratch with the new PocketBeagle 2. And I will take complete control over all the images that it will produce in my workshop. Also, it will be intelligent so I don't waste recording space because it can detect persons like me and intruders. Lately, a lot of companies have proven that you cannot trust them at all. Even if they claim that local mode won't send your data to some servers, it's just a lie, maybe. So trust is never justified. You always have to check and control. So my security camera is of course built from scratch. I use the PocketBeagle 2. I control every single aspect of the hardware. I use open source hardware and I write the software myself. And I publish this all openly. So if you want to build your own security camera, you can take this as a basis and you are not reliant on any dodgy cheap electronics that may or may not do whatever with the images from your private spaces. Sorry. You may expect a Raspberry Pi for a streaming webcam, but I'm using the PocketBeagle 2. I had some experience with the PocketBeagle 1 before. It wasn't as easy to use as the Raspberry Pi. It's not as beginner friendly, but this is a lot more flexible and it has some features that make it special, and especially for this application, I'm using the internal battery management of this. It also has USB ports exposed on the GPIO pins, and I will likely use a USB camera as the camera of my project. And overall, this also has some other nifty features that I will use on future projects, so I want to get accustomed to it. Get started on like a basic project first. Oh, and one thing that separates the PocketBeagle from a Raspberry Pi is this boots very fast. It runs an AM6254, I put it down below the exact processor by Texas Instruments on there, but this boots like in a few seconds and it's already usable and reachable over the network. But this doesn't have onboard network, it has something different. My initial idea was to mod this fake security camera into a real one. So if I deploy a lot of these, you won't be able to tell which ones are the real ones and which one are the fake ones. But I also want to put a camera outside, and this is not up to the task. It's a fake security camera after all, and there is no weather protection. But I will reuse the glass and the swivel arm bit, because this is still cheaper to get this thing and not use most of it than to just buy a swivel arm by itself. So I'm using a different weather-tight case for my camera. So the Hammond 1457 series has weather-tight enclosures. They also have EMI-tight enclosures. We've used that in a previous video. But this one has gaskets around its ends, so there's no moisture coming in and out of this. And because it has slots inside, I can use these to directly mount my PCB. Speaking of that, I also have to mount a USB camera. I'm using a USB camera. It comes with a cable, but I'm not actually using that. I will directly wire it into my custom PCB. But I also have to mount this inside the enclosure, and I've made a 3D printed part that exactly slots in and keeps this perfectly in place and aligned with the front. This is the prototype printed from PETG just to see if it will fit, and the full part is then printed in black ASA. I got this from Multicom Pro, and this turns out to be a very resistant material. You can smash this a bit, so it's almost like ABS, but it prints a bit nicer. And this is also not susceptible to heat, and inside the case will get quite warm because there's a real computer running inside. So I don't want to have any drooping on my 3D printed parts, and with ASA that's not the case. For the PCB, I also utilized 3D printing. In FreeCAD, I've drawn up the perfect size for my PCB, leveraging the original manufacturing data by Hammond. They just give you that, and you can model your files before you even get the part, so you know the cases that you order will fit. And then I used that 3D print to make sure that everything fits before I designed this PCB. Friendly, manufactured by Eisler again, and it came out perfectly, and it exactly fits. So there was 0.2 millimeters tolerance in size, and turns out, yep, that's exactly the right amount of tolerance. The PocketBeagle footprint that I used on this design does dual duty. It works for SMT and also THT components, so the header pins that you use to connect to the PocketBeagle, but it also exposes a bit more of the pad, so you can use this easily for bodges. In case you want to use your PocketBeagle on another board, you can use the short end of your header pins to connect it, because they have low profile headers already on them. So the PocketBeagle gets quite close to the original board, or you use normal length headers and stick it up more in case you want to put components underneath it. Of course, I could connect my USB camera directly to the USB 1 pins of the PocketBeagle, but then I could only connect that one USB camera. And I also need networking, because the PocketBeagle does not have any included networking capabilities. It does have USB tethering, I don't know. It's basically you plug in your USB-C cable and then it shows up as a network device on your computer. Then you can navigate to its IP address and log in via SSH as it was connected to the network. That didn't work for me very well. I constantly got connection errors on Ubuntu. Maybe this works better on other OSs, I don't know, and I don't care, because I can also use the same connection, the USB-C cable, with just a serial terminal, and I log in over the USB port and I have the exact same functionality, so it didn't matter to me. But once I have a network connection on there, like with Ethernet or Wi-Fi, then I can just SSH into my device, and also this directly works with VS Code, so that's quite convenient to develop on the PocketBeagle. To connect all these things at the same time, you would need to construct a hub. Oh, by coincidence, or not by coincidence, I spent most of the time on this project on connecting the hub in my design, a USB hub, 4 ports. I've been a bit of a burnt child with USB hub designs. I tried that before and I failed, and it was down to the crystal and its load capacitors. It didn't work out as it should. It was quite sensitive to that, so I was worried I wouldn't get it right this time. So I planned to use a ready-made oscillator. I ordered the wrong one. I ordered a 5 volt 24 MHz oscillator. Yeah, that was the wrong part, because it's a 3.3 volt device. Surely I would need a 3.3 volt oscillator. Tried out the oscillator with my trusty oscilloscope and the power supply, and turns out it also outputs a perfectly fine 24 MHz exact square wave at even 3.3 volts. So is there even like a physical difference in these two versions, or are they just marked differently? I don't know. But turns out this is also wrong, because even though the USB 2514 that I use by Microchip for this design, it doesn't expect a 3.3 volt oscillator level. A much lower one is needed according to the datasheet, so this would already fry my chip. So at the last minute I switched the design to the classic crystal and capacitor design. I did not have the right capacitors that I calculated. I would have needed 12 picofarads and I only have 10. So I'm pretty much gambling on that the series capacity, or the capacity of the traces, will have enough series capacity to still make it work with 10 picofarad capacitors. The only way to find out is to just try it. And that's what I did. There are a few more things on the board. There's a dual USB header, which means there's a stacked dual USB port on there that goes inside the case for some expansion capability. Then we have the USB port for the camera and another one facing to the outside. What is up with that, I'll tell you later. And then we have two other connectors, those are for batteries. In the beginning I told you that the PocketBeagle 2 has onboard battery management capabilities and can seamlessly switch from one power source to the other and back, which means even if you unplug the camera or if you shut power to the building, the camera is still recording. So the USB tethering was a bit unstable for me during development, but it turned also out that the network connection also just seemed to randomly stop working. And I couldn't figure out what this was for quite a long time. I tried like all the possible debugging stacks, especially on the network, because I thought it was like a network configuration error. Maybe the same error that gave me the USB tethering issues. But turns out that wasn't the case. What it was a power issue. My camera is powered over the 4th port, which is on the outside. And this one has a dodgy 4-pin connector. I forgot to order a good one. So this one leads to a junction box on the other side of a wall, so you do not have direct access to whatever is going on the network if you have access to the physical camera. And if you shut down all like the power and whatever, this still keeps on recording, and afterwards I still can spot you. So what's up with the power? The cable leads out through a wall and to this junction box that is homemade. It has a power supply made by Draco Power, and on the inside I soldered up some connections to a USB port, so I can install any other USB device on this end of the chain, which means this is where my networking, either Ethernet or Wi-Fi, will plug in, and you only have access to that from this side of the chain. So this power supply was chosen because A, it's like a DIN-mounted power supply, it's very convenient to use, but it also has a lot of power, 5 volts at 2.4 amps, much more than I would ever need. This is plenty enough for my device, even running under full load with full like person detection and whatever. But this also has a feature that makes it very valuable. You can adjust the output power very precisely, and this is exactly what I needed, because it turns out the issue with my network wasn't in the network at all. It was not a brownout because it provides enough current, but voltage drop. Under full load, my device will draw enough power to make the voltage drop by 0.1 volts. This is just enough to make the PocketBeagle stall. It should never fall under 4.8 volts, and it's just barely did. So with a little tweak with a screwdriver, I got this dialed in so it would never dip below 4.99 volts, and at idle it comfortably sits at 5.04 volts. So a very precise change in voltage, and that fixed all the issues. Welcome to the code void, and this time we don't have much code to go over. It's quite simple. We're running a web server on the PocketBeagle. It's all done in Python. We just use basic authorization to authenticate ourselves with a default username and password. You can change that in the code if you download it on element14.com, of course. And we have 3 types of running modes. We have none, which is basically, it's just a webcam. You can enter an IP address and you can watch the stream. Does nothing else. But if you define a detection model, then you can use Hog or DNN. Hog is a CPU running model that is very simple and it barely works. So this is highly dependent on how fast your CPU is running. So this is what we could expect from image detection models in like 2017, 2018, something like that, and not more. But DNN is a very lightweight system of running image detection on edge hardware, which the PocketBeagle 2 is. This is edge hardware. This is stuff that is out in the field exactly there and doesn't need any like API calls or whatever to the internet. It does all the interference locally on its own hardware. So this works very well. I have kept the frame rate a bit to allow for higher resolution, because what we need in a security camera is not perfect frame rate, but we need to be able to recognize whoever is in the image. So I would rather have lower frame rate for the detection, but higher resolution. And this is where the PocketBeagle really shines. It handles that gracefully. And it doesn't get very warm. I have added an additional heatsink to the PocketBeagle that is also connected with some heat paste to the outer case, so it will dissipate heat to the outside. And of course, because it produces warmth itself in the winter outside, it will also keep itself free of any frost, which is also quite handy. So it turns out using a bit of power to heat yourself, actually a good thing. So now with this quite simple code base, this is nothing for deploy, this is just so you can start your experiments with it. We can use these functions to actually do some useful bits. Instead of having it run continuously and recording all the time and then we have to scrub through footage, this is not the modern way of surveillance. We now detect if something has entered the room, and we can now detect by objects. So this model is now restricted to only people. So if a person gets in view of the camera, it starts recording. And if the person left the view for more than 3 seconds, it will stop it. And this way I don't waste the precious recording space on my SD card for any non-interesting video that I have to scrub through. No, it will only record whenever there's something happening that's of interest. And then afterwards I can simply download these files. And after 72 hours, they will automatically be deleted. Very nice feature. And if I would need more storage for some reason, well, there are the internal USB ports again. You can just add a USB stick to them and expand the storage. Since we're ready for a test run, I wonder if somebody would come through that door and do things in my lab. Better get the security camera ready. Never trust a device you haven't built from scratch. Now, there's a recipe for a security camera based on the PocketBeagle 2. So this works great, like a charm. I can access the stream from any point in the network. It automatically records whenever there's a person coming in, and I don't waste precious recording space. And if I have a fleet of these, suddenly every corner of my workshop can be surveyed with a device that I can fully control. If you want to take control over the devices that you built yourself, join the Element 14 community. We have a ton of projects on there. We have the files for this and many other projects for download for free. And if you want to chat with me and all the other Element 14 Presents hosts, we're also there. I gotta go. There's another project waiting for me.